we will take the material first. We just have half of the chapter left out. Okay, so we'll finish the material first, and once we finish the material, then we'll be discussing in detail about the researchers. Okay, so you can bring all your questions in the next half. So we in this chapter we have been discussing about the catabolism of various biomolecules, whatever we eat, whether it's a carbohydrate, whether it's a protein, or whether it's a fat. Okay, so in the previous class we discussed about the glycolysis. We discussed how a glucose molecule is converted into two molecules of pyruvate, okay, with the release of energy. Okay, in today's class we have to actually discuss about the pentose phosphate pathway, but before that let's discuss about the energetics. What is energetics? That means what did we basically actually achieve at the end of the glycolysis, right, or at the end of the aerobic respiration. If you remember, we spoke about initially about the aerobic respiration, which has 4 stages. Okay, so glycolysis was the stage 1. Okay, wherein, if you remember, we discussed last time that we had gained 2 ATPs, right, at the end of the glycolysis, and we also produced 2 NADH at the end of the glycolysis, right, and 2 molecules of pyruvic acid. So that was something which we gained at the end of the glycolysis. Okay, very important. So all these questions are asked in the exam, so you have to be careful about the energetics part, okay, the energy yield part, whether it's a TCA cycle, glycolysis, or electron transport chain. You should be knowing about all these things. So let's discuss this first and then move on to the other pathways, the pentose phosphate pathway. Okay, so in the previous class we learned that in the glycolysis the first 3 steps are the activation steps. Okay, where we convert the glucose into the fructose 1,6 bisphosphate, and then we use 2 ATPs. That's what we discussed in the previous class. If you remember, I have a cycle here. So we used 1 ATP here and we used 1 ATP over here, right? So if you remember that. And then what we did is that then we have the step numbers are wrong over here. It's not step 5 and 6, 9. Okay. So then we learned that in step number 6, if you remember, we did here in step number 6, what did we produce? We produced 2NADH. Okay. Because if you remember, we said that after dihydroxyacetone phosphate is converted into glyceraldehyde 3-phosphate, so we will have 2 molecules of glyceraldehyde 3-phosphate. So that's why the word 2 you will find everywhere over here. Okay, don't forget about that. Okay, so while doing so, we produced how many NADH? We produced 2 NADH. Now you might be wondering, if we produced 2 NADH here, why did we write 4 over here? Okay, the reason why we write 4 over here, for every NADH, okay, we are still using the old method, okay, in your as per your textbook. Okay, uh, for every NADH, okay, which is produced not in the mitochondria, which is produced in the cytoplasm, okay, one NADH is equal to how many ATPs? One NADH is equal to how many ATPs? This is very, very important thing to remember. Is equal to how many ATPs? Anybody? 2 ATPs. 2 ATPs. I wanted this kind of detail in the in the assignment which I had given previously. Uh, so that was about, okay. So we have 2 ATPs, right? So since we have 2 NADH, so of course we'll have 4 ATPs produced over here. So these are 4 ATPs produced over here. Then, if you remember, we also produced 2 ATPs, right? If you remember, we produced, right, here and here. Look at this, right? We produced how many ATPs? We produced 4 ATPs. 2 here, okay, sorry, 2 here and 2 here. 2 in step number 7 and 2 in step number 10. We produced the 2 ATPs, right? So these are the 4 ATPs which I have mentioned over here. Okay. Now what happened? So this was what we this was what we gained or lost in the glycolysis. So all this was what? In the glycolysis, the first phase of the cellular respiration. Okay, Okay. Then if you remember, once we produce the pyruvic acid or the pyruvate, right, this is the end product of the glycolysis. We produce two molecules of pyruvic acid. If you remember, we said that if oxygen is present, if it's an aerobic respiration, what will happen to this? It will be converted into acetyl CoA. Remember? Acetyl CoA, right? And while doing so, when it was converted into acetyl CoA, okay, we also produce how many NADH? We produced what, 2 NADH in this process. So that means when we convert pyruvate into acetyl CoA, we produce how many NADH? 2 NADH. Since the reaction does not take place in the cytoplasm, it takes place in the mitochondria. So we will say a very, very important lesson this is, very, very important part of this is. So please remember all this. 1 NADH will be equivalent to how many ATPs? This was the assignment last time. Can anyone tell me? If we go with the old method, because your book is all about the old method. Does anyone remember how many ATPs? Exactly, Shatha, 3 ATPs. Absolutely. So because the reaction takes place in the mitochondria, so we'll have 3 ATPs produced here. So since we have 2 NADH, so that is why 3 twos are 6, right? So 3 twos are 6, right? So we'll have 6 ATPs over here. Okay. Then if you remember the last stage, the third stage of the respiration, which we discussed in the last chapter, right? We are in the acetyl CoA. This acetyl CoA will enter into the what? TCA cycle, right? What was the gain in the TCA cycle? What did we get in the TCA cycle? Does anyone remember? What did we get in the TCA cycle? Does anyone remember? How many NADH? Mohammed, I'll say 3 NADH. Absolutely. In the TCA cycle, we got 3 NADH. This is something which I'm explaining it from the previous chapter. 3 NADH, very good. Right? We produced, very good. We produced 1 FAD. So this should be on the, on the tip of your tongue. This is so very important. FADH2. We ask plenty of questions from the energetics part of it. Okay. And 1 GTP, absolutely, which is equal to 1 ATP, right? This is what we produced in the TCA cycle, which will be taken to the what? To the electron transport chain to fetch the energy, right? So that's what we're going to apply over here, right? So if you remember 3 NADH, 1 NADH is equivalent to how many? Let me show you. Oh, let me show it you here. So 1 NADH is equivalent to how many ATPs, guys? So can you convert all these in the ATPs? How many ATPs we'll have? Yes, so we'll have 3 ATPs here. So 3 into what? 3 into 3, isn't it? So we'll have 9 ATPs over here, correct? 1 FADH is equal to how many ATPs? 2 ATPs. Very good, everybody's writing, very good. So how many ATPs we'll have here? 2 ATPs. And of course, we'll have 1 GTP, so which is equal to 1 ATP. So 9, 10, 11. What is the net gain? We got 12. This is something which I'm explaining from the previous chapter. We got 12 ATPs at the end of the TCA cycle and the electron transport chain. Very good. But you have to be very careful. We got, very good, Mohammed. I was going to say this and you replied, right? This, you have to remember, this is per pyruvate, right? Not per pyruvate, per acetyl CoA, to be more specific. It's not the pyruvate which enters into the TCA cycle, it's the acetyl CoA which enters the TCA cycle. So this is per acetyl CoA. That means 12 is produced, a very, very important part. 12 ATPs are produced from one molecule of acetyl CoA, right? So you will, accordingly multiply it with the 2. So 12 into 2 will be 24, right? That's how. So now, do you know that how did we get this 24? Everyone, very, very important part. As I said, that we do ask many questions, and and your midterm 3 is going to be calculated twice. You know, your these four chapters are very important because it's going to be calculated for the midterm 3 as well as for the final exams. So please remember, ladies and boys, everyone, right? So that's how I got this 24 ATP. So if I add them all together, 24 plus 6 plus 4 is going to make how much? 34. 34 plus 4 is going plus 4 is going to make 38. Out of 38, I used 2 ATPs over here. What is my net gain? The net gain after my aerobic respiration is 36. We do ask questions based on on each and every part of the respiratory cycle, or we do ask or we ask the overall net gain. Okay, so please remember these tables are very important. So this is what we get at the end of the aerobic respiration, 36 ATPs. Right? Even though now, because of the new method, this has been changed. So I will not go into the new method, if that might confuse you all, because now we say that for every NADH, we have 2.5 molecules of ATPs are given. That is like a new method. When they did new researches, they found that no, we don't get 3 ATPs out of one NADH. We just get 2.5 ATPs out of one NADH. And same thing changed for the FADH. As for the new method, it says that we get 1.5 ATPs, from one FADH2. Okay, so accordingly, the overall thing will be changed. It was not 36 now. We usually say it is the 32 ATPs now. But that might confuse you. I will not go with the new method. We will stick to our textbook, so that we'll stick to the old method of ATP production. Nobody is going to ask you about the new method. Are we okay about it? Everybody? If you remember, this is the same slide which I got from the previous chapter. This is the same slide. That's how we calculated. 3 NADH, 1 FADH2 will give you. So 12 ATP, remember I have not mentioned it here, but you need to know this is per acetyl CoA. Okay, this is per acetyl CoA, but you need to multiply it with the 2 because we know that there are 2 acetyl CoA molecules produced. Do we have any question about it till now? Okay, okay, alhamdulillah. Because as we move on, so as I said, that this energetics is not only important in the examination point of view. You will go, as you will go in College of Medicine, they always in biochemistry, they're always after these energetics. They might, so if your energetics is clear, this is like, oh my god, you know everything about these cycles. Okay, because students usually tend to get confused with the energetics part of the cycles. Okay, so that means you have won not half of the battle, the entire battle of biochemistry you have won, if you know what is the energetics part in the biochemistry, especially in these cycles. Okay. Now let's move on to the next cycle, which is called as the pentose phosphate pathway. Okay. And now you might think that what is it pathway all about? Okay. You know that we produce glucose 6 phosphate in the glycolysis. Okay. If you see here, I will go to the cycle once again. Okay, we produce what? Glucose 6 phosphate in the first step of the glycolysis. So what does your pentose phosphate pathway say? Pentose phosphate pathway say that this glucose 6 phosphate, which is produced in the first step of the glycolysis, can also be used by other purposes in our body. See, we know that this glucose 6 phosphate will be converted into fructose 6 phosphate and all that, right? It will go into the process of glycolysis. But it says that, it can be used for something else also in the body, right? So no need to send it through the glycolysis. If you have enough energy available, just deviate it from the glycolysis. That is why pentose phosphate pathway is sometimes called as a pentose phosphate pathway shunt. Right? What is shunt? Shunt means deviation, detour. Okay, you're going to university, and in between you met a friend and she told you, no, no, let's not go to the university, let's go to my friend's place first. So you took a detour, right? You visit somewhere else. So that's why it's called as a pentose phosphate, a pentose phosphate pathway shunt. Okay, wherein the glucose 6 phosphate, which was supposed to go into glycolysis, isn't it, which was supposed to form the pyruvate in the glycolysis, okay, but it takes a detour, it gets shunted away, okay, and it is used to produce something else, okay. So now the question is, you might ask me a question, what are you going to produce from the glucose 6 phosphate, okay. Glucose 6 phosphate, again, it can be used in the cytosol. So if the question says that, let me go to the pathway. If the question says that where does it take place, I forgot to mention it here, okay. Where does it take place? It also takes place in the cytoplasm, cytosol or cytoplasm, pentose phosphate pathway. Okay, it's also sometimes called as a PPP, just PPP, or just called as a shunt pathway. Okay. Now you might think that what are we going to produce out of it? We usually produce the ribose 5 phosphate. As you can see over here, look at this. I have ribose 5 phosphate produced, okay, from the glucose 6 phosphate. Okay, and this ribose 5 phosphate I can use for the synthesis of what? Do you remember RNA? The sugar in the RNA, the ribose sugar in the RNA, right? So I can use this sugar in the RNA to produce my RNA synthesis. Point number one. Is it okay? Okay. Now, what are the other things which I'm going to produce out of this? Okay, glucose 6 phosphate. Out of this glucose 6 phosphate, if you see here, along with the ribose 5 phosphate, I am also producing NADPH. Okay, so your glucose 6 phosphate can be oxidized by this pentose phosphate pathway. Okay, and it produces the NADPH. So this NADPH is used at various other places. You don't have to know where, but you can just say that it's used, for example, whenever we have to produce unsaturated fatty acids in the body, whenever you have to produce steroid, remember the steroids in the body. This is used for the cholesterol synthesis in the body, okay. And if it's a plant cell, it's used in the photosynthesis, okay. So this NADPH is also used by the RBCs, okay. You know, the RBCs uses NADPH. If I have an RBC, so RBC also uses NADPH as a defense mechanism, okay. They want to protect themselves from the oxidative damage in the body, okay. So it can be, so you don't have to name the things because it's not mentioned in your book. You only need to know what is the outcome of the pentose phosphate pathway, what do we produce at the end, okay. So we can say that you produce ribose 5 phosphate, which can be used for the synthesis of the RNA, and we also produce NADPH, which can be used at various places in the body. Okay, no need to mention about the fatty acids are produced, cholesterol is produced, amino acids also produced, right? And RBCs also use them, right? So that was about the pentose phosphate pathway. So as I said that for every pathway, always think that what did I start with and what did I produce at the end, and how much energy did I generate it here. Okay. Yes, NADPH. Yes, absolutely. The reducing agent. Okay, it's because it's a cofactor, isn't it? Yes, yes, Muhammad, it's a cofactor, right? So that's why it can be used at various places in the body. Okay, but what do you think, if the body needs the what, if the body needs the glycolysis, what should be the main aim of glucose 6 phosphate at that time when we require energy in the body, right? So glucose 6 phosphate will remain in the what, in the glycolytic pathway. It is not deviated to the pentose phosphate pathway. This can happen only when we already have a lot of energy present in the body. You can still take it to synthesize all these things. Is it clear about the pentose phosphate pathway? Any questions about it? Okay, alhamdulillah. Okay, so this is the same thing what I explained. This is the same thing. This is the same thing from the last chapter. Okay. Now, if you remember when we started this chapter, okay, when we started discussing this chapter, I will go back to the main diagram, which when we started here, I told you that time that look at this. We finished this part, carbohydrates, okay, how they enter into what glucose enters into glycolysis and produces the pyruvate, and we also produce the acetyl CoA if the oxygen is available, and then the oxygen is available, then all these stages will be completed, right? We did all this part, but now we need to discuss this and this part, okay, wherein it's just trying to show you that we can, if carbohydrates are not available, okay, if carbohydrates are not available, can we still use other biomolecules as a source of energy? Yes, we can. We do, right? So we can also use lipids. We'll start with the lipids first and then move to the proteins. So yes, we can use lipids as the source of energy, wherein the lipids are converted into the glycerol, right? So because we need to break down the lipids to the fatty acids and the glycerol, we cannot use triglycerides, right? So this glycerol can enter into the glycolysis. So we will see how the catabolism of glycerol will take place. So this we'll discuss now, and after this we will discuss that even fatty acids which we produce from the lipids, right, those fatty acids can also form the acetyl CoA, right, which is an intermediate of the aerobic respiration, and that can be used to generate or to produce the ATPs. So we are not only dependent on the carbohydrates for the source of energy. We can also use lipids, and then at last we'll discuss about the how proteins are used as a source of energy. Right. So right now the two things which we have to discuss is how glycerol can enter into the glycolysis, and how fatty acids can be converted into the acetyl CoA, right? So they can enter at the pathway anywhere in the middle. Not They don't need to start from the beginning. They can end. If you see here, amino acids are also entering over here in the citric acid cycle. So they can enter at any step of the aerobic respiration and generate the energy or ATP. Are we okay about it? Any questions? Let's start using discussing this glycerol. Okay, how we can use glycerol, right? Okay, so we know that, as I said, the triglycerides will be converted into monoglycerides or the glycerol and the free fatty acids. So we'll be talking about the glycerol first. Okay, this one. Okay, so glycerol will enter into the glycolysis, as we saw previously in the previous diagram. Glycerol can enter into the glycolysis, right? But how can it enter into the glycolysis? It can enter into as a dihydroxyacetone. Can anyone tell me at which step we have dihydroxyacetone? Mohammed, Guide, Shatha at step number 5. Very good. Everybody is so active, mashallah. Very good. Alhamdulillah. Absolutely. You're right. If you see here, this is step number 5. You will have dihydroxyacetone. So glycerol can simply form what? Dihydroxyacetone, and then rest you all know what is going to happen after that. Right? And how does it take place? It takes place, first of all, we have the activation step. Okay, this again, where does this take place? Again, this takes place in the cytosol, because plenty of questions are asked about all these things, the locations. Where does glycolysis take place with the TCA cycle, pentose phosphate pathway? So remember the locations also. So the catabolism of glycerol also takes place in the cytosol or in the cytoplasm. Okay, so what happens, this glycerol is first activated. Okay, if you see here, I used it, and we use an energy first here. Okay, so we took the phosphate from here and we added the phosphate at carbon number 1 over here. Look at this. Okay, so you can say that what happens, the glycerol phosphate is oxidized by the sorry, that's the second step, right? So glycerol phosphate is oxidized by the NADH, okay, and then it forms the dihydroxy acetone. So this is the second step what is happening over here, okay, wherein the oxidation is done by the NAD positive, which gives us NADH here. Okay, so we used 1 ATP here for the glycerol, activated it to glycerol 1 phosphate. Then we used NADH, okay, and then we converted this into the dihydroxyacetone phosphate, okay, and then after that, what is happening? Once we have the dihydroxyacetone phosphate, and then you already know that the isomerization will take place, and the rest, the things will continue for the glycolysis. Okay, is it clear to everyone? Did you all understand what is happening here? So we just have two steps here, right? One, this is the activation step, which I explained you. And then the second step, which I explained you how glycerol 1 phosphate will be, okay, oxidized by the NAD to produce the dihydroxyacetone phosphate. That is it. Okay. So we finished this part. We finished this part. Now we'll move on to the fatty acids. Okay. So fatty acids, basically how we can use, as I said, that we can convert triglycerides into monoglycerides and the free fatty acids. Okay. So here now we will be using the fatty acids as the source of energy here. Okay. And what is our aim? Our aim is to convert these fatty acids, as you can see here, to convert the fatty acids into the acetyl CoA, and then that acetyl CoA can enter into the TCA cycle. And rest you all know that. So this is what we are going to discuss now, and it is called as a beta oxidation of fatty acid. Okay. So before we could discuss that, we already know that if we have to compare the energy generation between glucose and the lipids, we know that the energy generation by the lipids is, we already discussed this in the lipid chapter, is almost double what is produced from the glucose, right? So just 3.8 kilocalories per gram from the glucose, and look at this, 9.3 kilocalories we get from the from the lipids. Okay, so this is something which you already know about it, right? So that is why we usually store fats as the are stored as, you know, mostly as the adipose tissue, so that we can use them in future for the energy generation. Okay, and then we have here the beta oxidation of fatty acids. Now, as I told you that this is our aim. Our aim is to convert fatty acids into the acetyl CoA. Okay, so how are we going to do this? Okay, how are we going to break down these fatty acids and produce the acetyl CoA? Okay, first of all, you might think that why is it called the beta oxidation of fatty acids? Okay, the reason for that is basically because we are basically the oxidation takes place at the beta carbon. If you remember, this is the alpha carbon. We discussed about it, the alpha and the beta and the gamma carbons. This is our functional group, right? So this is the alpha carbon, this is the beta carbon over here. So that is why it's called as a beta oxidation of the fatty acids. Okay. So should I start? Any questions till now? Now, the first question which we asked to ourselves, where does it take place, isn't it? So that is the first question which you should always ask to yourself. That is about this takes place in the mitochondria. Okay. Now, what is the reaction one over here? Reaction one is we need to activate, we always have activations. We saw that activations in the glucose also. Glucose is activated to glucose 6 phosphate, right? So what happens is that the first step is the activation step. Okay, in the activation step, what do we do? Okay, we simply activate the fatty acid, and this is again the energy, you know, consumption step. We use ATP over here. We don't produce any ATP over here. We use ATP over here, right? And we also use coenzyme A over here. So these are things which we are going to use to activate this fatty acid. Okay, so we use one ATP molecule. Okay, and if you see here, we have used both the bonds of the ATP. That is why AMP was produced, right? ATP has has two phospho anhydride bonds. Okay, so both the anhydride bonds of the ATPs were hydrolyzed, right, to produce the what? The acyl CoA. Along with that, we also release some amount of AMP and the phosphate. Okay, so what did we do here? By using that energy, we linked this coenzyme where? To this fatty acid. Didn't we do that? Look at this. This is my fatty acid, and this is my, let me get another color. This is my coenzyme. I've linked my coenzyme to my fatty acid, and what did I get? I got acyl CoA. Did you all understand the first step, everyone? Okay. So this step is, first of all, okay, this step you have to remember that, as I told you, you have to ask yourself a question. Okay, the first step, this first step, okay, this first step is the only one which takes place where? In the cytoplasm or in the cytosol. Okay, cytosol. Then it has other process wherein, that is not mentioned in your book, wherein this one, this acyl CoA will be taken into the mitochondria. Then all the other steps will take place where? In the mitochondria. Very important thing to remember here. The question says that the first step of beta oxidation of fatty acid, where does it take place? So what will you answer? It takes place in the, yes, ladies, if the question says that where does the first step of the beta oxidation, where does the activation of the fatty acid take place? In the cytosol. Very good. Then you have to say that this, then the fatty acids are what? Transmitted or sent or transported to the mitochondria. Let's see step number 2. In step number 2, what is simply happening here? Okay, you will see the two hydrogen molecules will be removed, one from the alpha carbon, another from the beta carbon. Okay, so step 2 is simply we will have an FAD. So oxidation will be done by the FAD, and you will see the two hydrogen atoms will be removed here. Okay, and as a result we will end up forming what? A trans enoyl CoA. Remember the, what did we form at the end? So what is the enzyme here? An acyl CoA dehydrogenase is the enzyme, right? Simply removal of two hydrogen atoms and forming a trans enoyl CoA, right? So this is an oxidation step. Okay, step 3. Step 3 is we are using water over here. Look at this. Okay, so it is the hydration step. So step 1 is oxidation, step 2 is hydration, where you use water. Okay, and you will, from the a trans enoyl CoA, we are going to add water here. Okay, and as you see here, there's no double bond now. It will result in the formation of the alcohol. Okay, so you have simply added OH group to this double bond, and there's no double bond now over here. Now look at this. This is an alcohol. So what did we form? We formed alcohol in the hydration step, and the enzyme was here was enoyl CoA hydratase was the enzyme. Okay, so step 1 was oxidation. Step 2 was step 2 was oxidation. Step 3 is hydration. What is the step 4 now? Okay, step 4, if you see, we're again doing oxidation. This is again an oxidation step over here. Again oxidation by the NADH. Okay, and if you see here, I have beta hydroxy acyl CoA. I have an alcohol here. Look at the functional group. Okay, I have an alcohol over here, and what did I convert it to? The, can anyone tell me which functional group do we have here? What is this? Can anyone tell me? Can you identify the functional group in the product in step 4? Ketone, absolutely, Shatha, Muhammad, both of you, very good, right? So we have made a, so alcohol is converted into a ketone by the action of the enzyme beta hydroxy acyl CoA dehydrogenase. So dehydrogenase, you're removing the hydrogens from here by using the NAD as an oxidizing agent. Okay, and then we have the step 5, which is the last step. So step 5 is a cleavage step. Okay, so after doing oxidation, then hydration, then again oxidation, and now the splitting step. Okay, so in the splitting step, what did you do? We had this ketoacyl CoA. Okay, and this is the place where we will produce the ATP, and which will later on produce the ATP. But what do we produce here? We produce here the two important compounds called as the acetyl CoA. So this is going to give us ATPs, but when? Where will this acetyl CoA enter, guys and girls? This acetyl CoA will enter into, how will it give us ATPs? TCA cycle. Very good. So this will enter into TCA cycle and will give us the ATPs. Okay. And at the same time, we produced a fatty acid which has 2 carbon less. Okay. Now I want everyone to pay attention, because this was a time when I remember last year when we gave this question, couple of questions on the beta oxidation of fatty acid. There plenty of mistakes were there in midterm 3 basically. Okay, so because in midterm 3 we had this chapter, so please pay attention, everyone. Is everyone connected with us? So I want all of you to pay attention at this place, because as I told you that this was a place, because we had given, it was not a numerical question, it was a very very easy question. Okay, but see, sometimes when we don't pay attention in the classroom, right, and when the instructor is trying to explain, okay, so when we don't pay attention to small petty things, then we end up making a mistake in the exam. So I don't want you all to make any mistake, right? Because you know that I always believe in, going to the past, and I always try to find out what mistakes students have done, so that my upcoming students never do this mistake again, right? So this is always my basic aim. I always try to go back to all the exams and try to find out what was the problem there, why students lost marks. So when I remember, I still remember, we had a midterm 3. This chapter was there in the midterm 3, and we all had given questions about this, me and Dr. Saddam as well. So, and then students, like most of the students, made mistake over here, right? So please pay attention what I'm going to explain you now. Okay. Okay, so as I said, that what is the product we produce? We produce the acetyl CoA here. Okay, and then we also produced a fatty acid which has 2 carbons less than what I started with. This is very important thing. That means if I started, let's say I started this with, let's say I started with this C18 carbon. Let's say R was, let's say we had C18 carbon. Nobody is going to give you the which lipid or what lipid. Concentrate on the number of carbon atoms, right? So let's say we started with the C18 fatty acid. Okay, so I completed my 1 beta oxidation of fatty acid. So at the end, what will I get here? I will get here C16 minus 2, because 2 carbon atoms are where? With the acetyl CoA. Okay, so I produced acetyl CoA, and the product had what? 2 carbon atoms less with what we started. So this will be only C16. Okay, so now what will happen? This is not going to stop over here. Okay, now this acyl CoA molecule will become a substrate for the next cycle. It will become a substrate. Okay, it will become a substrate for the next cycle. What does that mean? That means the C16, whatever fatty acid it is here, I'm not bothered about that. I'm more concerned about how many carbons I have here. So this 16 will again go back and start the reaction 1, right? So next time what will I have? I will start with C what? 16, isn't it? So all the steps are going to get repeated in the next round. All the oxidation, hydration, and then again oxidation. What will I have after in round two? What will I have in round two? C14 plus acetyl CoA, isn't it? Yes or no? Because after this, the problem is coming up after this. So tell me if you didn't understand this. So I've simply said that after one round of beta oxidation of fatty acid, we produce an acyl CoA with whatever carbon atoms we started. If we started with 20, so after round one, we will have what? C18 plus one acetyl CoA, right? So what will happen? Whatever we produced here, this acyl CoA, this will again go back to the round one and start again beta oxidation. So this process will continue. After C14, what will we have? C12, right? After that, what will we have? C10, then C8, then C6, then after that it will be, then we don't need to do one more, right? Because at that time we will have here two carbon atoms and we'll have here two carbon atoms, right? So that will be the end product of it. So the idea is basically, what you need to remember here is that the substrate which is formed over here, right, the product which is formed over here, that product becomes the substrate. It's used in the next round of the oxidation. Okay, and every time when the acyl CoA is formed, you have to remember that it contains two carbon, right, less than what we started with the original acyl CoA. Okay, and this will continue till the fatty acid will completely oxidize, and at the end we will have two molecules of acetyl CoA. That time we will not have acyl CoA. In the last one we will have two molecules of acetyl CoA. Did we all understand this one? Because as I said, that the problem is coming after this. Do we have any question about it till now? Okay. Okay. Now moving on further. Okay. For example, okay, let's say I started with, okay, let's say I started with, okay, let's say, okay, we just did 18 so that, because we started, I told you the 18 one, right? So let's do the 18 one. Let's say I started with C18 over here, as I told you. Okay. So can you tell me, when I started with the C18, can you tell me at the end of the beta oxidation of the fatty acid of C18, how many acetyl CoAs will I produce? And this was the question, which we asked in the midterm. Okay. We basically asked the question, how many acetyl CoAs are produced at the end of the beta oxidation of the fatty acids? Okay, and how many cycles would be required to produce those acetyl CoAs? I'm not confusing you, I'm repeating it once again. We started with C18, okay, and if I ask you a question that, tell me at the end of the beta oxidation of fatty acid, how many acetyl CoAs did you produce? Okay, and how many cycles did it take to produce those many acetyl CoAs? This was the question. Now, let me see if what you can answer, then I will explain you. Okay. Can you tell me with C18, if I have a fatty acid with C18, how many acetyl CoAs I will produce and in how many cycles at the end? 18 acetyl CoAs and 9 cycles. No way. See this, as I said, that everybody gets confused with it. Don't worry. I will explain. No, not 16 cycles. 7 cycles, Amjad, very close. 9 cycles, no, 9 cycles. Amjad is correct, 8 cycles. And how many acetyl CoAs? How many acetyl CoAs? 16 cycles and no. How come 16 cycles? Hmm. Remember, every cycle you're just removing 2 carbon atoms. How come 16 cycles? 9 acetyl-CoAs. Very good, Amjad. Very good. And 8 cycles. You're correct. 9 acetyl-CoAs. No, no. The question is about the acetyl-CoA, the sheet. You're correct, Amjad. 9 acetyl-CoAs and 8 cycles. You are correct. Can you explain, Amjad? Can you switch on your mic and explain how did you get the 9 acetyl-CoAs? Then I will explain it. Or if you want to write down the answer, you can switch on your mic. That would be much better, Amjad. We'll get to hear your voice as well. Your answer is absolutely correct, Amjad. 9 acetyl-CoAs and 8 cycles. But how? That's my question. You can't. But how did you know the answer? Okay. Okay, ladies, I'll explain you how this works. Okay, give me a minute. Let me open a screen, a blank screen, a white screen. Okay. So please pay attention. Let's say, okay, 18 will be too long for me to do it over here. Okay. I will do something, a smaller one over here. I will do with the C10. Let's say I started with C10. Okay. So what is happening at the end? So please pay attention, everyone. So I have, for example, let me make C10. 2, 3, 4, 5, 6, 7, 8. Oh my god, 9 and yeah, 10 should be okay. Yes, C10. Okay. So what happens after every cycle? You produce an acetyl CoA, right? An acyl CoA with 1 carbon, with 2 carbons less. That means after you finish your cycle one cycle of beta oxidation. So how many carbons will be less? 2 carbons will come out as an acetyl CoA. Is it? Yes or no? 2 carbons will come out as an acetyl CoA. Yes or no? Right? So how many carbons I will have after round one? This is my round one. After round one, I will have 1, 2, 3, 4, 5, 6, 7, 8 carbons. Correct? Round one. Absolutely. Oh my God, you guys are intelligent. Okay. Now we are doing C10. Now I want all of you to pay attention over here. Please, everyone. Okay, please, everyone pay attention. Okay. So I used here the C10 carbon. Now after round two, what happens? One more acetyl CoA I will produce after round two of oxidation, right? So this is my round two, correct? So this time when I produce one more acetyl CoA, and now I will have 1, 2, 3, 4, 5, 6, isn't it? So in the round one, I had how many? I had C8, isn't it? And now round two, I have what? C6. So this will be my round three, correct? So 2 carbons are coming out as an acetyl CoA. So this is my round three, correct? This will be my round four, correct? Round four of beta oxidation. And this will be my round five. So that means after 5 rounds of the beta oxidation, Faiza says 5 acetyl CoAs and 4 cycles. Very good, Faiza. Absolutely. But let me explain them. Very good. Absolutely. Right? In C10, I will produce how many? The question was how many acetyl CoAs you will produce. So I produced 1 in first round, second, third, fourth, 5. Right? So I produced 5 acetyl CoAs. 5 acetyl CoAs. Am I correct? Okay. But how many rounds will it take? If I say that this is my round one, correct? This is my round two, correct? Right? Now we have to find out how many rounds will it take. So if you see here, What I did here, and nobody told me about that, I did that deliberately. If you see here, round 3 and round 4. When I'm in round 4, do you think I need to go back in round 5 once again? Because at this time, I will already have one acetyl CoA here and one acetyl CoA over here. Because every acetyl CoA has 2 carbon atoms, isn't it? So do we need a round 5? Of course not, right? So I don't need this round 5, because at the end of round 4, what do I have? At the end of round 4, I already have my 2 molecules of acetyl CoA. So you will say that we will produce 5 acetyl CoAs, okay, in the beta oxidation of C10, and we will produce in how many rounds? 4 rounds. Isn't it clear? Is it clear to everyone? Did you all understand now? So 4 rounds, or we can say 4 cycles now. Now, you will not make all these carbons in the exam. Of course not. You will say, no, no, we are not going to make all these carbons. Tell us something, a formula. What I developed a formula to make things easier for my students is like, remember that if you have to calculate the number of acetyl molecules, okay, simply divide it by 2. It's pretty much easier now. If I give you C20, how many acetyl CoAs I produce? What will you do? C20 divided by 2, 10. Absolutely. If I give you C18, how many acetyl CoAs? 9. Remember that. So for the acetyl CoAs, remember whatever number if I give you in the exam, whatever number is given, okay, if it's 20, whatever divided by 2, and it will give you the number of acetyl CoAs. Correct? So that means 10. Now, what will you do to calculate the number of cycles? Okay, if the question says that, tell us the number of cycles which are, how many cycles will produce 5 acetyl CoA molecules. Okay, if the question says like that, how many cycles will produce 5 acetyl CoA molecules, right? So for that, the simplest formula is you will do, and this is totally developed by me, I just wanted to make things easier for my students. So n minus 1, tell me if it's correct. N divided by 2 minus 1. What is n? Number of carbon atoms. So n is here. If I apply it here, 10 divided by 2, right? What is it? 5. So 5 minus 1 is equivalent to 4. So it will give you the number of cycles. Super easy now. Isn't it clear now? So remember these formula. In order to calculate the acetyl CoAs, divide n by 2. If you have to calculate the number of cycles, n by 2 minus 1, right? Because the last cycle, thank you, Tashil. Thank you for the compliment. Thank you, dear, for the compliment. Because I saw last year students struggling with it. Last year I did not give them the formula. This I discovered, and this I basically made after, because I'm really very much, when my student does a mistake, I'm very upset about it. Why didn't I teach her well? What was there? So I explained them all this last year, but what I missed on last year is I did not give them the formula. They understood the concept, but then they made, some of them, not everybody, but most of them made the mistake, in this was a question which was given by Dr. Saddam, I think, and me as well. There were 2 questions based on this, I think. Okay, so this, I didn't want this to happen again. This is very, very important, and you can use this in College of Medicine as well. Okay, so remember this formula. So do we need any explanations? Because this doesn't end over here. We still have something else coming up. Tell me if you have any doubts about it. Anybody? Okay, what about C14? How many acetyl CoAs in C14? If I give you C14, how many acetyl CoAs? 7. Very good. And how many rounds? 6, of course. Thank you. 1. That means you understood it. Okay. Let us go to the next slide now, right? So you now know it that, okay, if we started with, if we started with, how many carbons we have here? So 16 is here, 17 1 here, and 18 over here. Okay. So so how many cycles over here? So how many I mean 16 over here, right? How many acetyl CoAs over here? 8 acetyl CoAs, right? And now what you need to know is that, sorry, 9 acetyl CoAs and 8 cycles. Yeah, 9 acetyl CoAs, 18 are here, right? I was correct. 16, 17, 18, 18 carbons over here. And we will have 9 acetyl CoAs and cycles will be 8, right? 8 cycles over here. Now the question is, there is one more question which is usually asked about the energy production also. Sometimes the question is about the energy as well. Okay. So after one cycle, let's do the energetics part of it. Okay, let's see how many ATPs are produced, okay, from a stearic acid which has C18 carbon. Okay, so this is the same C18 carbon, right? So in the C18 carbon, what did we say, that how many acetyl CoAs? 9 acetyl CoAs, and we have 8 cycles. Okay, now in one cycle, okay, we saw that when we did the activation part, okay, I'll go back to the slide. When we did the activation step 1, what did we use? We used 1 ATP over here, right? So initially we used the ATP to activate the fatty acid. Okay, look at this. I use the ATP over here. So this is the energy utilization step. I use the ATP over here. Then comes your oxidation. Okay, if you remember, we did the oxidation step, right? This one. Okay, we did the oxidation. And what did we produce? We produced one FADH2 we produced. Okay, and then if you remember, in another step, step 4, we produced one NADH. Let's try to apply all this. Okay, I produced, okay, one NADH over here, one FADH over here, one NADH over here. Okay, then just leave this one for a while. Okay, let's concentrate on this one. Okay, since I have, sometimes the question is about the energetics. Okay, since I had 18 a fatty acid with the 18 carbons, so how many in one cycle I produce one FADH. Okay, and what do I produce? I produce one NADH, isn't it? And I use two ATPs. So what do I produce in one cycle? One NADH and one FADH2, right? And how many ATPs I use? I use two ATPs. So if I apply all this over here, okay. So how many cycles? We had 8 cycles. Remember, we had 8 cycles over here, right? So how many NADH will you produce? So activation will use two ATPs, okay? So in the oxidation step, when you produce one FADH2, so how many cycles? 8 cycles, isn't it? And 8 times you will produce the FADH2. Is it correct? So one FADH2 will give you how many ATPs? 2 ATPs. So 8 into 2 is 16. Did you all understand how did I calculate this? So when you know your number of cycles, okay, it can also tell you how many NADH or FADH we produced. And the mistake which students had done last year is, when the question like this was given, they thought that, okay, for example, if I gave them a question about C18, they thought, oh, C18, it produces 9 acetyl CoAs. That means 9 NADH. Okay, because we will not give you the same carbon atom in the exams. We might change the carbon atom. I will repeat. I will repeat there. I will repeat once again. I said that, okay, you did one cycle. Okay, let me go back. You did one cycle, Gada, right? In one cycle, what did you produce? Let me go back. What did you produce in one cycle? Here you produced one FADH2, correct? Let me write it here. You produced one FADH2 at the end of one cycle, correct? I also produced one NADH at the end of one cycle. Yes or no? Here is my one NADH, right? Did I produce anything else? No ATP. No, not at all. No ATP, isn't it? So my question is that in one cycle you produce one FADH and one NADH. So how many FADH or how many NADH you will produce in a fatty acid with the carbon 18? Now tell me. if in one cycle I produce one FADH and one NADH, how many FADH and NADH will you produce in fatty acid with the C18 carbon? Everybody is lost. Nobody is replying. Guys, did you all understand? No, you didn't understand, right? I know, confused. Okay. Okay, how should I make you explain this? Give me a minute. 8. Okay, 8 FADH. Absolutely, Faiza. Okay. Okay, this is, I just want to tell you that, okay, if we have whatever, for example, I had C18 fatty acid, okay, at the end, how many acetyl CoAs I produced in the C18 one? How many acetyl CoAs did I produce? Okay, very good. We produced 9 acetyl CoAs. Very good. 9 acetyl CoAs. 9 acetyl CoA. How many cycles? You had 8 cycles, correct? 8 cycles. Okay. When I converted my C18 to, in the first cycle, when I converted C18 to C16, okay, in my first cycle I produced one FADH and one NADH. That is it, isn't it? From my C18 to 618 C16, I produced one FADH and one NADH, correct? Then second time when I went from C16 to 6C14, I produced one more FADH and one more NADH, correct? From C14 to C12, I produced one more FADH and one more NADH, correct? Right? So all you need to know is that the number of cycles, simply remember the number of cycles which will happen, obviously that many number of FADH will you produce, because in one cycle we produce only one FADH and only one NADH. Did you all understand? So in short, whenever you get a question like this, what you need to do is that just calculate the number of cycles, right? Because you know that in one cycle I produce one NADH and one FADH, right? So obviously if I have 10 cycles, I will produce 10 NADH or 10 FADH. Okay, if I have 20 cycles, I will produce 20 NADH and 20 FADH, right? So simply remember the number of cycles which you have in that particular fatty acid, that many number of FADH and NADH you are producing. Is it clear now? Tashil, Faiza, Gada, is it clear there? Gada, is it clear? Really, it's clear? Okay. Can you tell me how many NADH will you produce with the C14 carbon? If I give you C14, Gada, I want you to answer. If I have, if I give you C14, very good. Absolutely. You'll have 6 cycles and 6 NADH and 6 FADH. Absolutely. You got it. Wonderful. Wonderful. Right? Okay, so that is what I was telling you in this cycle, that we started with C18. So how many cycles we had in C18? We had 7 cycles, right? 7 cycles. Correct or not? Yes or no? 7 cycles or 8 cycles? 8 cycles. Isn't it? Absolutely. We had 8 cycles. 8 cycles over here, right? So as I had 8 cycles, obviously that many number of FAD I produced here, and that many number of NAD I produced here. So 8 times and 8 times here again. Okay. But then you might think that how did we get this 16? Because we know that FADH is equal to how many ATPs? FADH2 is equivalent to 2 ATP. So 8 multiplied by 2 will be 16 ATPs. Absolutely. So I will have here 16 ATPs. Right? Again, here I know that here I'm producing the NADH. I know that one NADH is equivalent to 3 ATPs. Right? So 8 multiplied by 3. 38 is equivalent to 24 ATPs I produce. Okay, is it clear? And remember, I have used here 2 ATPs that I will come up to it later on. Now you might think that how did this 108 come here? Can anyone explain this 108 here? Let me erase this. How did we get this 108 here? This one. Let me see if anybody can do it. This is something which we studied previous and just now we studied it. Mm-hmm. Thank you, Mohammed. Everything is clear. But no, tell me the calculation for this 108 molecules of ATP. How did we get that? Oh my God, wonderful. Absolutely. Remember, one acetyl CoA molecule, remember once again, one acetyl CoA molecule will enter into the TCA cycle, right? One acetyl CoA molecule will enter into the TCA cycle and produce how many ATPs, right? Will produce 3 NADH, will produce 2 FADH2 and 1 GTP. It produces what? We just did that here. It produces how many? 12 ATPs per acetyl CoA, right? This is from the last chapter. From one TCA cycle, we produce 12 ATPs from one acetyl CoA, right? So obviously, if I have nine acetyl CoA, 12 multiplied by 9 is 100 and whatever it is, 108. Did you understand how did we get this 108? So let's add them all together. So I have 108 ATP from the TCA cycle, 24 here, 16 here. Okay, can anyone add this and tell me how much it is? 120, 30, 40, 148, correct? Yeah. So we produced 148 molecules, but how can we forget that we used 2 ATPs? So minus 2 ATPs. So my net yield is 146 ATPs. Tell me now, how many of you did not understand this? Because for sure, as I said, that we do give questions, if not here and College of Medicine also. This is something which is very basics and very important. Tell me if you didn't understand. I will really make you understand once again, because I don't want you to make any mistake in the exams, right? Because in the exams, we might not give you the same carbon atoms. We might give you any carbon atoms. Can you do one problem quickly? Let me see if you have understood. Okay, yes, Island, I want everyone to do a problem. Tell me about C14 carbon. Let's say I had a C14. Tell me how many ATPs can we get at the end, and tell me also how many acetyl CoAs and how many NADH, FADH cycles, everything. 100. Yes, Tanya, I will explain that. Yes, Tanya. Tanya, for that you have to remember that one acid last chapter we said that, Tanya and Island, that one acetyl CoA molecule enters into the TCA cycle. This is from the last chapter, right? Which was the homework. That was the homework as well. So we said that one. This is the slide from the last year chapter, right? We said not last year. I mean last chapter. We said that one acetyl CoA, okay, one acetyl CoA enters into the TCA cycle and combines with oxaloacetate and all that. It produces, we say that it produces 3 NADH, 1 FADH2, and 1 GTP. Okay, that means for one acetyl CoA, we produce 12 ATPs. Right? If the question says in the exam that how many ATPs are produced in TCA cycle, okay, you will say 12 ATPs, isn't it? Tanya, is it clear? 12 ATPs. Did you understand, Tanya and Island? So 12 ATPs we produced from one TCA cycle, right? From one acetyl CoA molecule, right? But then if I go back to what I produced here, how many acetyl CoAs did I produce? I produced 9 acetyl CoAs, right? So 9 multiplied by 12 you will do, which will give you 108. Tanya and Island, is it clear, dear? So you simply have to multiply it. So everything you will get to know once you will come, once you will know your acetyl CoAs, once you will know whenever you get this kind of question, first of all calculate how many acetyl CoAs I produced. First of all, you know write that how many cycles did it take to produce that many acetyl CoAs, right? So the number of cycles will give you the number of FADH2 and the number of NADH2. So then you can add them up with the TCA cycle, because you know that in TCA cycle we have 12 ATPs produced per acetyl CoA. Then you can multiply it with the number of the cycles which you had. Nobody came up with the answer yet. I had given you the question about C14. I know it will take a little time. I'm waiting here, don't worry. If you want to share your screen with me, you can share your screen also. I've given you the permission. So I think Lean said C14 will have 7 cycles. No, the opposite. Okay, good. 6 cycles and 7 acetyl CoA. Good. Amjad came up with the answer. Let me read. Amjad said 7 acetyl CoAs. Okay, 6 cycles. Very good. And 112 ATPs. Very good, Amjad. Amjad, can you write down, the breakup? How many in the activation? How many in oxidation? That way, it will help the students as well. People who have Amjad, Gayed, people who have done this, if you just can write the breakup also, that can help the other students as well. Okay, very good, Amjad. You're right. Guide says 7 acetyl CoA, very good, 6, absolutely. But you didn't write guide about how many, that was the question, how many ATPs? Pfizer says 7 acetyl CoA, 6, very good. 84 ATP, no dear. How come you got 84 ATP, Pfizer? Do it once again. Do it once again. Island says 7 CoA, acetyl CoA, very good. And how many cycles, Island? Guide says 120. No, 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 not 120. ATPs are ATPs are not coming up correct. If anybody wants to share their screen, you can also 7 CoA, very good. 6 cycles, one absolutely 112. You're correct. Tashir, if you want to share, you can share, the breakup of it. Or I've already given the permission if you want to write down on this slide. Let me erase all this. You can write down here on this slide. Anybody, if you can volunteer to write down, I've already given the permission to share, to write on my slide. I just need the breakup also. Oxidation 6 into 3, 6 into 3. No, I will not understand this way, Lian. Not this way. This, I want this format. Give me in this format. In activation, how many, in oxidation, how many, in oxidation, how many, and then at the TCA. This one you can number it as a TCA cycle one. TCA with the electron transport chain, TC and ATC. This one you can number it this way. Oh, you forgot to. No. You will get overall. No. Is it overall 112 you got, guide, or after taking out 2 ATPs you got 112? Yes, overall 114, and then very good, guide. Absolutely correct. Faiza, for every one NADH, you have 3 ATPs. Remember, for every one NADH, you will get 3 ATPs. For every one FADH2, you will get 2 ATPs. Faiza. What about others? Why? Where is Muhammad today? He didn't write the answer yet. Gada Dehman 114. Gada Dehman, what about 2 ATPs using at the end? Remember the first step? Maybe you forgot to minus this one. Gada, check once again. Yeah, minus. Yeah, very good. Absolutely. Mohammed 7 acetyl co is 6 cycles, 6 FADH2, very good. 6 NADH. Okay, 7. What about, okay, what about the others? You didn't add them up, Mohammed. The last one step. Yes, for the total 112. Absolutely. Very good. TC1 is 84. Absolutely, you're correct. So lean says activation -2, oxidation 12. Yeah, 12. 3 6 are 12. Okay, oxidation 8. 2 6 are 12. Okay, 3 6 18. Okay, very good. And TCA is 12 into how many you had? Go is 7. 84. 12 into 7 is absolutely correct. Yes. Yes. This one is correct. Lean, thank you, dear, for sharing that. Yes. Ladies, everyone, this one is correct. Then -2. You're right. You're right. You're right. Absolutely, Mohammed. What about others? Why only few people are writing? What about others? Please let me know. I will re-explain it to everyone. Please let me know, everyone. Do you want me to do it? Yes, ladies? Yes, dear. I will do it. Okay, I will do it. Don't worry. Okay, let me get a plain sheet here. I want a plain screen. I'm doing it for you, no problem. I'll do it for you. Everybody, don't worry. Okay. So I said that the question was basically, I'm just spending more time on it because I don't want anybody to make a mistake. So, see, everybody, please pay attention. I said that what was the carbon number I said? I think 14, I said, right? Yeah. If we start with the, yeah, carbon 14. Okay. Now tell me, in carbon 14, what did I tell you about, what formula did I tell you about the to calculate the number of cycles? What was the formula? How many cycles will you have here? Yeah, what was the formula? Yeah, n, exactly. I told you n divided by 2 minus 1. So what is n here? 14 divided by 2 minus 1. So 2 sevens is 14, 7 minus 1. So that means how many cycles? 6 cycles, correct? Okay, great. Then I said that if you need to calculate the number of, very good, Razan, yes. If you need to calculate the number of, so 6 cycles I would require to make how many molecules of acetyl CoA? Then I told you how to calculate the number of acetyl CoA. Simply, what will you do? Yes, divide this 14 by 2. So n by 2, that is 14 by 2, will simply tell me that I have what? 7 acetyl CoA. 7 acetyl CoA. 7 acetyl CoA. That means if I start my beta oxidation of fatty acids with the fatty acid which has 14 carbon atoms, okay, at the end of 6 cycles, I will produce how many acetyl CoAs? 7 acetyl CoAs. Right? That's what we mean, right? So at the end we'll produce 7 acetyl CoAs, right? Now in these acetyl CoAs I told you, you also need to calculate how many NADH you produce. Then I told you, if you know your number of cycles, okay, that many NADH you will produce. So that means, Yomna, how many NADH will I produce in 6 cycles? I produce 1 NADH in 1 cycle. Yes, absolutely. Very good there, right? So you will produce 6, you will produce 6 NADH, right? At the same time, you will also produce 6 FADH2. Are we okay till now? Okay. Everybody, are we okay? We know now this number of cycles. We also know now how many NADH, FADH we produce. We also now know how many acetyl-CoA will produce. Khalas, right? And then we remember the format. What was the format? In the format, we said that, okay, in the format, we said that in the activation step, okay, I'll go to the diagram to show you the, in the activation step, we use two ATPs, right? I'll go to the diagram once again. I'm going to erase this. Give me a minute. In the activation step, we use two ATPs. So I will write here, I'm going to use two ATPs. Okay. So remember how many cycles we had earlier? You know, we had 6 cycles. Yes or no? Okay. So I had 6 instead of 8, I have 6 cycles here. And I know this is FADH2, and I know FADH2 produces how many ATPs? 2 ATPs. So what will I do? 6 into 2. So I will get here what? 12 in the carbon atom, which was C14. Are we okay till now, everyone? Yes, Razan, everybody? Yomna, are we okay? Okay, okay, great. Okay. Now I know that I had how many cycles? I had 6 cycles. I have 6 cycles here, right? So 6 cycles, and I have how many NADH? One. I have 6 NADH, right? And I know one NADH will produce 3 ATP. So 6 into 3 will be 18. Correct? Okay. And again, see, the number of cycle calculation is very important. So I have 6 cycles here again, right? So I know that when my acetyl-CoA enters into TCA cycle, it produces 12 ATPs, isn't it? So 12 multiplied by how many? Yes, how many acetyl-CoAs I have? 7 acetyl-CoAs, right? So I have 12 multiplies by, because I produce 7 acetyl-CoA. Here you need to know what? You need to know the acetyl-CoAs, not the cycles. Okay, I have 7 acetyl. Let me erase this. I have I have 7 acetyl-CoAs produced, right? So I produced 7 acetyl-CoAs, right? So 12 multiplied by 7 will be how much? It will be 84 to 7, 14 and 2, 7, yeah, 84, correct, right? So when I have 84 over here, if I'm going to add all this now, 84 plus 18 and 12 and 2, 18, 90, 98, 80, 90, 100 and 114, right? So we'll get 114 is the number overall. But how can I forget that I have to do minus 2 over here? So 114 minus 2 will give me 112. Now tell me, did everyone understand now? Aileen, I told you 1 NADH is equal to 3 ATP. 1 NADH is equal to 3 ATP, dear Aileen. Maybe is my voice breaking? I told you 1 NADH is equivalent to 3 ATPs. And 1 FADH2 is equal to 2 ATPs, Aileen. Clear? Okay. So we have spent a lot of time on this question, but I hope it was worth it. Was it? You didn't? Okay, Gada, I'll tell you why. Because we use 2 ATPs here. This one. In the activation step, you know, you always have to minus the ATPs which we used here. Gada. We always use 2 ATPs. Yes. That is like always there. Okay. Yes. So that one you have to minus. For the activation one, we use to, in order to activate the fatty acid, the first step of it, right? We use 2 ATPs there. Yeah, the first step, this one. The first step over here, this one. Because if you remember, I told you here, this ATP is converted into what? AMP. That means I have broken two anhydride bonds. So I've used two ATPs here. So you remember always this two will be there. Whatever the carbon number is there, you have to minus two over there. Right? Great. Now moving on to the next topic called as the ketone bodies. Oh my god, okay, dear, no problem. We still have lots of things to discuss. Okay, so ketone bodies. So have you ever heard about ketone bodies before? Anybody? What are ketone bodies? Maybe people who are writing diabetes, they might be knowing about what are ketone bodies. If your topic is diabetes, no, no ways, nobody. Okay, okay, that's okay, no problem. Okay, so basically what happened, what are ketone bodies and when do we produce them? Okay, so we saw that whenever we have to metabolize the fatty acids by the beta oxidation, right, we know that we will get at the end the acetyl CoA. Okay, and we saw that previously that beta oxidation will continuously remove two carbons, right, until and unless we get what, at the end we get the acetyl CoA. It will be continuously there, and then we said that this acetyl CoA will enter into the TCA cycle to produce the further ATPs. Okay, but this acetyl CoA which we formed over here, okay, this acetyl CoA which we formed over here, this acetyl CoA can also be used, okay, in the liver to produce something called as the ketone bodies. That means if you're eating a fatty rich diet, maybe today you did not eat carbohydrates, you ate a fat rich diet, your diet was mostly rich in fatty acids. Okay, if you ate a fat rich diet, that means your liver is flooded with the fatty acids, for example, right? So that means we will produce large amount of acetyl CoAs, and then some acetyl CoAs will enter into TCA cycle and produce the energy. But then there are a lot of acetyl CoAs produced, right? So what are you going to do with so many acetyl CoAs, right? So what's going to happen in the liver when we have large amount of acetyl CoAs present? Not all of them enter into the TCA cycle, right? Even the ketone diet. I'm going to talk about the ketone diet as well. Yeah, never do never do ketone dieting. I mean the keto diet, not the keto diet. Yeah, yeah, I'm going to talk about that as well. Okay, so that means this acetyl CoA will not, all of them will not enter into it because you are already producing a lot of ATPs, but you have large amount of acetyl CoA. So what will happen, these acetyl CoAs will combine together to form a molecule which is called as an acetoacetic acid. Did you all understand what I'm trying to say? When we have large, whatever the reason it is, whether you're eating less carbohydrates, whether you're doing a keto dieting, whether you're starving. See, right now we all are fasting. Right now we are not eating carbohydrates. What is my, see, I have been talking since morning. I have been using energy since morning. What do you think, what is the source of acetyl CoA right now in my body? I might be breaking down the fat as a source of, right now this is happening in everybody's body, your body, my body, right? We are right now using fatty acid as a source of energy, isn't it? Even in the starvation, even in when we are fasting, right, at that time our liver is flooded with acetyl CoA because we start using fat as the source of energy because we are not eating carbohydrates, but the body has to go on, right? By body cannot stop. Or even sometimes even the diabetes, which is not a controlled diabetes, because because diabetic people, they don't have carbohydrates available, right? So what happens at that time when you have large amount of acetyl CoA, so the two acetyl CoAs will combine together, will join together, they form the acetoacetic acid. As you can see here, see, it forms the acetoacetic acid, this one. Okay, and this acetoacetic acid will also be converted into beta hydroxybutyric acid or to the acetone, right? So please remember, everyone, sometimes the question is like this. So name the ketone bodies. So whether it is the acetoacetic acid, whether it is the beta hydroxybutyrate, or whether it is the acetone. So all these three compounds together are called as the ketone bodies. Are we okay? Did you all understand? Yes. So, how did we form the ketone body? As I said, that the reason is as we are fasting right now, or you're on a keto diet, or you're starving yourself, or the diabetes is uncontrolled, where there is no carbohydrate, right? So, we might produce lot of ketone bodies, and these are the three ketone bodies which are produced in the liver. So, what is your body going to do? Your body has to go on, your brain has to work, right? So, these ketone bodies will be released into the blood and will be sent to your skeletal muscles or sent to your brain, right? So that the body can derive what? Energy from these three ketone bodies. Now you might be wondering that how is it possible? How can body produce energy from the ketone bodies? Yes, they can. This acetoacetate will go back to my brain or to my skeletal muscle. It is again converted to what? Acetyl CoA. And acetyl CoA can enter into what? TCA cycle and produce, and which can enter into electron transport chain and produce the ATP. And I'm going right now. This is what is happening in my body right now. The ATPs which I'm using right now, they are produced maybe from the what? From the ketone bodies, which is released by the liver and sent to the skeletal muscle or to the brain or wherever it is required. Are we okay till now? Did you all understand what I'm trying to say? Now if you produce nominal amount of acetone bodies, you're okay, we are okay. Right now we know that by the end of we will break our fast by 6:15 or 6:10, right? We will eat something carbohydrate or whatever we will eat, we are all okay. So we did not produce lot many ketone bodies. But people who are nowadays dieting, they are doing keto dieting. What do? They don't eat carbohydrates. They don't, or they eat very little carbohydrates, right? Now you might think that what carbohydrates has to do with it. So what happens if you are not eating carbohydrates? Remember your TCA cycle. I don't know how many of you have memorized TCA cycle. What did we use with the acetyl CoA? Does anyone remember what was the first step of TCA cycle? Very important step, where we did condensation of what? Acetyl CoA and oxaloacetate. Very good, guys, right? And then in the first step, we produce the citrate. So that means acetyl CoA plus oxaloacetate, then only it can enter into TCA cycle and produce the ATP. But the problem is this oxaloacetate comes from your pyruvate or comes from your carbohydrate. So that means if you're not eating carbohydrates, if you're eating less carbohydrates in your keto dieting, why do we say keto dieting is bad? It's very, very bad not to eat carbohydrates, because our body does need some amount of carbohydrates so that it can produce the oxaloacetate, and then only this oxaloacetate will combine with the acetyl CoA and enter into TCA cycle and produce ATP. Did you all understand what I'm trying to say? Are we okay till now? Okay. Now let's say you are not eating you're on a keto diet. I know you want to reduce the weight. I know you're not eating carbohydrates. So that means either the oxaloacetate is not available for you because you're on a keto diet, or very less carbohydrates are there in the body. If very less carbohydrates are there in the body, so what do you have more? So there is less oxaloacetate which can combine with the acetyl CoA. Am I correct? I'm not eating carbohydrates. I don't have oxaloacetate. Can my acetyl CoA enter into the TCA cycle? Of course not, isn't it? So that means you will have accumulation of lot of acetyl CoA in your body, and this will, and because of the keto dieting, when you have lot of acetyl CoA, it will end up producing lot of ketone bodies, and these ketone bodies are acidic in nature. it will decrease the pH of our blood. So that is why keto dieting is so very bad that it can cause metabolic acidosis. People who have a topic of metabolic acidosis, they can understand what I'm trying to say, right? So they will suffer with the metabolic acidosis, right? And if they continue doing this keto dieting for a very long time, god forbid, if it's very severe, right, if acidosis is very severe, right, what's going to happen? God forbid, if it's untreated, a person can go into a coma and can also die. Okay, because lot of acidosis, lot of acidic, acidosis in our blood can depress our nervous system. So a person can go into coma. That is why we all should avoid keto dieting. If you want to do keto dieting, just eat some amount of carbo, reduce the number of carbohydrates, right? But don't completely shut down the amount of carbohydrates. Okay, that nowadays doctors do not recommend the keto dieting because of this reason. Is it clear, everybody? Are we all okay? Everyone? Do you all need a 5 minutes break? Because we are, we just have the last thing to discuss. I think another 15-20 minutes we'll finish. Yes, don't worry. You want me? Yeah, yeah, don't worry. I will give it. Okay, you can take a 5 minute break. Okay, and then we will come up for the protein metabolism, and then khalas, the chapter is finished, the syllabus is finished, and then we can start our round two of research discussion, research. I mean, that's what you understood. Okay, research article submissions. Okay, do's and don'ts about that. Okay, okay, dear. So you all understood the ketone bodies, right? No questions about it. Okay, great. So let's take a 5 minute break and then start with the last part of the chapter. It was very interesting. Thank you, Lee. Yes. So if you see somebody doing the keto dieting, please recommend them don't do it. Eat some amount of carbohydrates. Be it like the fructose from the fruits. Even if you eat fruits, that should be all okay, right? But we should not totally curtail them, from our diet. Yes, Gada. Yes, Gada. Don't worry, because as I said that we all, not me. I think everybody. I'm waiting till Thursday, right? For PHSF also till Thursday, how much we can finish in urinary system. And for today, I was waiting till I finish this last chapter, and then I can send you. I will write the name of all the chapters and send an email on e-learning. Gada, I'll do that there. I'm going to do that here because I was waiting to finish the syllabus for today. I'll do that there. Don't worry. Okay. Recording. Okay. So the last part of this chapter is how we use proteins as the source of energy, the catabolism of the proteins. Okay. So normally when we eat, if you see this diagram, normally whenever we eat proteins, let's say we had laham, or let's say we had a chicken, right? So a good meal of protein, when they all are converted into amino acids. We learned that in digestive system how they're converted into amino acids or tripeptides or dipeptides. Okay, and what happens from the digestive system? They pass on to through the hepatic portal vein. They pass on to the liver, which we already discussed in digestive system. Okay, so what happens to these amino acids in the liver? Okay, liver is the only organ, remember, that has all the that has all the pathways for the amino acids, whether we need to make more proteins or whether we need to synthesize, right, degradation, right? So everything liver has it. So liver plays a very, very important role in it. Okay. So there can be two scenarios. If you ate a protein rich diet, if you have less protein, okay, in the body, so anabolism will take place. What is anabolism? From this amino acids, you will synthesize more proteins in your body. Okay, and what happens most of the times, this will happen. So whenever we eat protein rich diet like fish, like chicken, for example, that those amino acids will be used what, to synthesize more proteins. in the liver or in other tissues. Okay, can you give me some examples of proteins in your body which we use everywhere, which can be made out of the amino acids? See, our body is full of proteins, and at every part of the life we use proteins, right? In every process we use proteins. Can you give me some examples of proteins which can be produced from these amino acids? Keratin, very good. For the hair, very good. Keratin for the hair. Fatima, anybody else? So now we are almost towards the end of the whole year. Now you should be in a position. Collagen for the connective tissue. Very good, Mohammed. Anybody else? Now you all should name enzymes guide. Absolutely. What is that? Actin, you mean, Noor? Actin, very good. Actin myosin, absolutely, very good. I want more. Go to the blood chapter. Go to skin chapter. Hemoglobin, very good, very good. What else? Albumin, very good, absolutely. Go to chapter number 9, ferritin, tropomyosin, actin. Yes, go to your chapter number 9, the hormone chapter. You will find plenty. Thyroxine, absolutely, very good. Epinephrine, norepinephrine, dopamine, very good, absolutely. I'm still expecting more. Go to chapter number 3 last semester. Chapter number 3, hemoglobin. Yes, somebody said hemoglobin, Mohammed. Go to chapter number 3 last, insulin, very good. Last semester, chapter number 3. Chapter number 3 last semester. Anybody? Remember the membrane proteins? Integral membrane proteins and the peripheral membrane proteins. Go to chapter number 4 last semester, melanin. Melanocytes produce melanin. What is that? It's a protein, right? Spindle fibers made up of protein. Mucus, you have mucin. Hemoglobin, keratin, antibodies, chapter number 12, clotting factors, right? So all these proteins will be made once we have a good rich amino acid protein diet. Okay, so this will be the primary. Yes, absolutely. Receptors for the, yeah, we just said that. Acetylcholine receptor, what are those? They are the membrane proteins. FSH, absolutely, all of you correct, absolutely, right? So this will be the first aim of the body, to synthesize all these proteins which we named over here, right? Whether it's a globular proteins, fibrous proteins, functional proteins, right? Or neurotransmitters, right? Or hormones. But, okay, if there are excess amino acids, because the problem with the amino acids is we can't store them like fats. We cannot. If you eat excess carbohydrates, yes, your excess carbohydrates can be stored in the form of the fat. But what will you do if you eat excess amino acids? Okay, these amino acids can also be converted, right, for the energy production. So when the carbohydrates are not available, right, we depend on the non-carbohydrate sources for the energy production. So yes, you can actually use these amino acids. We'll talk about what is an oxidative deamination in a while, right? When we remove this amino group over here, that amino group, we'll discuss also urea cycle here, will be converted into urea, will be excreted out. This will be excreted out. But then I will also have a carbon skeleton, right? Remember the structure of the amino acids. You will also have a hydrocarbon sector. You'll also have a carbon skeleton, right? So what will happen to that carbon skeleton? Okay, so that carbon skeleton will be used to produce the intermediate molecules. Remember, what is a pyruvate? When do we produce pyruvate? We just finished the glycolysis, end product of glycolysis. So this carbon skeleton can be used to produce the pyruvate, for example, right? So it can enter into the carbohydrate metabolism at various points. Okay, and then these will be further metabolized. For example, these can be metabolized to produce the ATP, the normal pathway which we spoke about. For example, when we are fasting and you are not eating carbohydrates, Or if you remember, we discussed about gluconeogenesis, using non-carbohydrate sources to produce energy or to produce glucose. Yes, we all can produce glucose, right? And that can happen from the carbon skeleton or the carbon form of the amino acids. Okay, or that is not all. We can also produce some amount of fatty acids from the proteins. How? This carbon skeleton can actually form the acetyl CoA, okay, and which can form these ketone bodies, acetoacetate, right, and which can also form the fatty acid. So we can use ketone also as a source of energy, especially in absence of carbohydrates, because your brain, your brain does not want anything else other than carbohydrates as a source of energy. But if you're not using if you're not eating carbohydrates, then even your ketone bodies can be used as the source of energy by your brain. So the process must go on, it must not stop. That is the basic aim in our body. It will not be stopped ever, right? So this was about the overview of the nitrogen catabolism. Now let's discuss all of these in detail. But before I could discuss in detail, did you all understand? Yes. So the first thing would be the deamination, because this is such a powerful, dirty thing in the body. Ammonia we don't want in the body. So by the oxidative deamination, we simply remove the amino group of the proteins, and you will see that in urea cycle, it will be converted into urea, which can go out of the body with the urine, right? With the as an excretory product. Okay. So now let's talk about what is the transamination and what is the deamination, right? So nitrogen catabolism in liver occurs in three stages: transamination, deamination, and the urea cycle. Okay, let's first discuss what is a transamination. So please pay attention. First of all, this structure is omitted. No need to prepare this structure. This one. So this is not related to, instead prepare this one. Even though this is a diagram which I brought from outside, but you need to prepare this one. Okay, not the structures, just the name. Okay, but no need to prepare this one before I start explaining what is the transamination. Is it clear to everyone? Okay. In transamination, simply, we have an enzyme called as a transaminase, and we also have a coenzyme called as a pyridoxal phosphate. Okay, so what do we do in transamination? Okay, in transamination, most of the amino acids in our body, okay, what happens, they actually, like, we have 20 amino acids in the body, right? So out of those 20 amino acids, like, almost 18 of the amino acids will undergo the transamination reaction. Okay, so what is happening in transamination? In transamination, you're simply amino group. Look at this. I have alanine as an amino acid. If you can see here, I have alanine over here as an amino acid. This alanine has an amino group. This one is an amino group over here, right? So in the transamination, the amino group is removed from the alanine, is removed from the amino acid, okay, to produce a carbon skeleton, okay, and it produces a carbon skeleton which is a keto acid, and here it produces the alpha keto glutarate. Okay, here it produces what? The alpha keto glutarate, and this alpha keto glutarate will be further used later on in the TCA cycle. You can use it, or as a various intermediate points you can use the what do you call it, the no the keto acid which we just produced can be used later on. Did you all understand? So it can be used. So as I said that these can be used at various other places. If you remember, I showed you here, right? So they enter at various places. Let me erase all this. Okay. So they enter at various places in the metabolic pathway. So they might enter here. If we have a TCA cycle over here, I think we have one more diagram for this. Okay, so they might enter at very, see, look at this. So these are very, see, this is alpha ketoglutarate. Look at this, right? So whatever amino acid you had, it produced the alpha ketoglutarate. So these are all intermediates of what? Of your TCA cycle, and which can be used to generate the energy. Did you all understand the transamination? So simply transfer of the amino group from an amino acid to the keto acid is called as the transamination. And what did we produce? We produced the alpha ketoglutarate, which can further enter into the what? Into the TCA cycle. Did you all understand? Okay, so it simply produced the carbon skeleton, and that carbon skeleton can be used, as I said, that I showed you, it enters into the TCA cycle, which can be used for complete oxidation, or it can also be used for the gluconeogenesis, where it can be used to produce what? Your glucose from it, as I showed you here, right? It can be used to produce the glucose from here. Is it clear to everyone what is transamination? Any question? Okay, then if you see here, as I transmitted this amino group to the alpha ketoglutarate, okay, it gave the, we basically, we removed the amino group, okay, and we produced the carbon skeleton. And if you see here, what happened, it gave rise to what? It gave rise to the what? A pyruvate also, and the glutamate also, right? So sometimes what happens, this transamination reaction is done by the body, okay, once, okay, it synthesizes the essential amino acids in the body sometimes, okay. So transamination reaction is the source of the what? Synthesis of non-essential amino acids also. Okay, is it clear? Is it clear? So this was a new amino acid which was created by this transamination. We not only have the intermediate produced, we also have what? We gave this amino acid to the alpha ketoglutarate. It produced what? It produced the new intermediate. It produced a new amino acid called as the glutamate over here, right? And then also produces the pyruvate, which can also enter into the TCA cycle. That is the transamination reaction. Any question about transamination? Are we all okay about it? Shall I explain the next one? The deamination. Yes. Okay. So D means what? Removal. D means removing something, right? So removal is basically, deamination is simply when the amino acid is catabolized to produce the energy, right? The amino group is removed first. So if this is my amino acid over here, glutamate, so this amino group will be removed. If you remember, I showed you here, this is the deamination. We remove the amino group because it's very toxic for the body, and this amino group can be converted into urea by the urea cycle. So what is a deamination? A deamination is simply a process where the amino group of an amino acid, okay, is removed, and it results in the formation of the alpha keto acid. Okay, in this process, this NAD positive is reduced to the NADH. But we also produce the ammonia, which is very, very toxic, which we can later on produce into the urea and throw out of the body. So ammonia and the keto acid are the products of the deamination. So ammonia, as I said, ammonia is highly, highly toxic and should be converted into urea as quickly as possible, right? So because if it's, once it's released in the blood, it's quickly taken to the kidneys. Kidneys will filter this, right, and will excrete with the urine. Okay, so this ammonia will enter into the urea cycle. So our next topic is the urea cycle. Should I start with the urea cycle? Everybody, did you all understand transamination, deamination? Very good. Okay. Now, what happens in the urea cycle? In the urea cycle, as I said, that what is the aim? The aim is we have to convert this highly toxic ammonium ion or ammonia, okay, into something which is less toxic, okay. So the less toxic will be the urea, okay. So the first step of the urea cycle is your carbon dioxide freely available in the body is combined with the ammonia, okay, and this carbon dioxide is present in the form of a bicarbonate ion in the body. We studied that in the respiratory system, right? And then what happens, we this is an energy utilization step. We will use 2 ATPs to produce or 2 ADPs, okay. So if you see here, this has been phosphorylated, so phosphate is added to it, and it will result in the formation of carbamoyl phosphate. Just remember the products over here. And these, yes, you need to memorize these products, right? Sometimes we do give question about when, for example, carbon dioxide combines with ammonia, what is it formed? When this combines with this, what is formed, right? So you need to please memorize this. Are we okay? So carbon dioxide plus ammonia gave us the carbamoyl phosphate, and we used ATP over here. Okay, is it clear till now? So this is the first remember, this is the very first reaction of the urea cycle. Do we have any question till now? Yes, ladies, boys, are we okay about it? We are doing urea cycle. Okay. So what do we have till now? We have the carbamoyl phosphate here. This carbamoyl phosphate, what will happen? It will combine with the ornithine. So this carbamoyl phosphate plus ornithine, okay, ornithine, okay, this is the ornithine, right? It will combine, these two will combine, it's a condensation reaction, okay, it will result in the formation of the second reaction compound, this is which is called as a citrulline. So the question says that which compound is citrulline? So this is the second product produced in the urea cycle, citrulline, okay. So what happens, this reaction takes place in the mitochondria. Then what happens, this citrulline will move out of the mitochondria, okay, it will combine with the aspartate. So citrulline is shown, there's a plus sign shown over here. Citrulline plus aspartate, okay, it will result in the formation of the, what is formed? Arginine succinate. It will form the arginine succinate. So this is the third one, okay, third reaction product. Is it clear? So citrulline and aspartate will be condensed together. Okay, it will result in the formation of arginine succinate. Okay, when this arginosuccinate is formed, then there is a splitting will take place. What is splitting? Splitting is this, I have arginosuccinate. Okay, now there is a splitting is a lyase reaction. Remember the chapter enzymes, lyase reaction, the splitting reaction, right? So this will be split into two compounds. Okay, one is called as the fumarate. Remember the names also. This is number one. Okay, and number two is the arginine. So arginosuccinate will form the fumarate as well as the arginine. Is the first product in the urea cycle carbamoyl phosphate? Yes, dear. Sham, the first product is the carbamoyl phosphate. Yes, dear. Yes, dear. Right. So as I said, you need to remember which is the first and which is the second product. Sham, are you with me or with Mr. Muhammad? I remember you. I given you permission. Yeah, yeah. Please go ahead. Sorry, I'm sorry. I remember that you're with Mr. Muhammad. but I was just wondering how come you're in my class. So that's okay. Okay, so so what did we say? So we have the arginosuccinate. Okay, what will happen to arginosuccinate? It will break down. Okay, as you can see, it will split, right? As a splitting will take place, it's a lyase reaction. Okay, it will result in the formation of fumarate and the arginine. So in this urea cycle, you can expect the questions like, what do we start with? What do we end with? What is the first reaction compound? What is the second reaction compound, right? So these kind of questions you might expect here. So, or for example, arginosuccinate, it's what does it form after the lyase reaction, okay, or after its breakdown. So it forms the fumarate and the arginine. Just make a flow chart out of it without the structures. No need to know the structures. Okay. So what will happen now? We have the arginine and the fumarate. Let's see what will happen to these two. Okay. So arginine will further break down. Okay. And it will form two things. Arginine will, let me write down here, it will break down. It will break down. Okay. And it will form two important compounds, one called as the ornithine and second one is the urea. So what did we do? We started with a highly toxic ammonium ion. Okay. And what do we have at the end? We again have a toxic compound, but it's very less toxic than what we started with. Ammonia is highly toxic for the nervous system, but urea is less toxic than that, right? And once this urea is produced, okay, then it will be released into the blood, it will be taken into the kidneys, and it will be excreted into through the urine. Can anyone tell me what will happen to ornithine? Let me see how many of you can figure this out. What will happen to ornithine? Did we use ornithine before? Does ornithine go back to? Yes, very good, guys. Absolutely, you're right. Your question has an answer. Ornithine, if you remember the first step, carbomoyl phosphate plus ornithine. Where is it? Remember the first step? This carbomoyl phosphate, this one, okay, it combines with what? With the ornithine, the condensation reaction to give what? To give the citrulline, right? Yes, very good. So you can reuse the citrulline again. You can reuse this ornithine again and again, right? So this urea will simply, as I said, that the reaction will takes place in the liver. So once the urea is formed, it's secreted out of the liver, it's excreted in the urine, right? And then okay, and that's it. That it goes out of the body. And remember one very important thing. Okay, if you observe this urea, how many nitrogens we have? I think this was a question maybe last year or maybe before that. How many nitrogens we have in the urea? Did you observe this part? Urea has how many nitrogens? It's not only removing the ammonium ion which we started with, it's removing one more nitrogen. Did you see that? It has two nitrogens, right? Look at this. One is here and one is here. So that will tell you that how good urea is in excreting the product. So one a nitrogen which it has, it's basically it's the source, this one, this is the source of it, right? The ammonium ion. Okay. And the second nitrogen which it got it from the aspartate. So there was a question something like this. The urea, remember, I will repeat once again, urea has two nitrogen atoms, as you can see over here, right? There's a one nitrogen atom it got from the ammonium ion, right? Which the starting compound, right? We started with the ammonium ion to excrete that out of the body. It's highly toxic. And the second nitrogen ion, it got it from the aspartate, which joined in the middle. If you remember, we said that citrulline will condense with the aspartate to form the arginosuccinate, right? So remember this point here in the urea cycle. Do we have any questions after this? Are we okay about it? Yes, ladies. Okay, now the last part of this chapter, don't worry, I know you all are tired. The last part of this chapter is basically very important part. Again, this is something, which you need to memorize. It's a very, very important part. Okay, this you need to memorize. What is it? So please pay attention. This is the last part of the chapter. Give me a minute. Let me use my charger. Give me a minute. Okay, yeah. So this is the last part of the chapter. If you remember when we started with the protein degradation, okay, what did I say? I said that when proteins are converted into amino acids, and these amino acids can form the carbon skeleton, right? Okay, if you remember this step, it can form the carbon skeleton, right? This carbon skeleton can be used to for the glucose, can be used to produce the glucose by the process called as a gluconeogenesis, or it can also be used to form the acetyl CoA to generate the energy, to generate the these fatty acids or the ketone bodies, right? Now what happens, and then we also said that the ammonium ion is removed and it's converted into urea, which we discussed right now. Okay, now if you see these amino acids, I told you that these amino acids can be part of various, intermediates in the TCA cycle. Okay, that's what I told you. If you remember, I said that. Let me show you the diagram. I explained you that these amino acids can be part of various, this is a TCA cycle, right? And these are the intermediates of the TCA cycle, right? So amino acids, different amino acids can form different intermediates of the TCA cycle when we are not eating, for example, carbohydrates as the source of energy, or when we have excessive amino acids available in the body, right? But now we have divided these amino acids into basically three types. One is called as the glucogenic amino acids, right? And another one is called as the ketogenic amino acids. And you will see that there are some amino acids which act as both. When I say both, what does that mean? That means they are both ketogenic as well as they are glucogenic. Okay. Now, what are glucogenic amino acids? Those amino acids where the carbon skeleton of, after removing the ammonium ion, okay, the carbon skeleton is used to produce what? The pyruvate or the oxaloacetates. So they can be degraded not only to pyruvate and oxaloacetate, these amino acids can also be degraded to other intermediates of the TCA cycle, be that your oxaloacetate, be that your fumarate, be that your succinyl CoA, be that your alpha ketoglutarate, right? So they can be a source of any of these intermediates so that the energy can be generated. So they can be converted into glucose by the gluconeogenesis, as you can see over here. Here we produce the glucose after this. But then there are certain amino acids which are ketogenic. So after removing their amino group, which can be later converted into urea, the carbon skeleton of these amino acids are degraded to what? To form the acetyl CoA or the ketone bodies. And I explained you that we can also use these ketone bodies as a source of energy, especially your brain can use that, right? Or it can be supplied to your muscles. We spoke about that, right? But we don't need to generate them in excessive quantities, right? So yes, these ketone bodies can also be used as the source of energy. Okay. Now, after memorizing the definitions about these two, what you need to know is, okay, you need to know this table. So this table is important. You all should know this table. Is everybody listening? I know you all are tired. We are just about to finish. Another 5 minutes, we'll finish this. Okay. So because a lot of our time went in basically when we when we were doing beta oxidation of fatty acids and how to do the calculations and all that, right? So I know you all are tired. Just give me 5 minutes and we're about to finish. So you need to know which the questions usually we ask, For example, which amino acids are glucogenic and ketogenic, or which are both glucogenic as well as the ketogenic? So I will tell you the best way how to memorize it. You might think that, oh my God, do I need to memorize so many amino acids? How is it possible? And you will not give me any mnemonic also. I don't even have a mnemonic for this, right? The only best thing about it is remember the ketogenic and the both one. Automatically, if you don't have this list and this list, whatever amino acid which if we would give you, they are all what? Glucogenic. Isn't that smart way to memorize things? Do you agree? Right? So no need to memorize this one. Just memorize which one are ketogenic. There are just two of them which are ketogenic, right? Which are used to produce the ketone bodies or fatty acids, right? But then there are some which are both, okay, glucogenic as well as the ketogenic, right? So obviously this one will be covered automatically, right? That means if you see here in this diagram, okay, tell me now, can you identify where is the, if I give you this diagram, can you identify which is the ketogenic amino acid? First of all, you have to go which are the ketogenic. We have leucine and lysine. Okay. So can you identify, if you see here, I have a leucine over here. Okay, and I have a lysine over here. Look at this. So these two are what? These two are your ketogenic amino acid. Remember this and look at this. They are used to produce what? The acetyl CoA, and they can also produce the ketone bodies over here. Okay. And then what about the both one? If you see that both are your isoleucine is both one. Phenylalanine, tryptophan and tyrosine. These are both one. You'll find them in both places. Look at this. You will find tyrosine here also as a ketogenic. And let me see where is tyrosine over here. Can I find tyrosine? Look at this. Tyrosine I have here also. Right? So this pathway, the purple ones which you see here, they are all glucogenic. So the both ones we will find them as the ketogenic as well as the glucogenic here, because here you will have all glucogenic ones. Okay. Then what about isoleucine? So isoleucine is also both. You will find it here in the ketogenic, and you should be here in the isoleucine here, right? So yeah, do we have to memorize what each amino acid is used to produce in the end? No, no, no. You just have to memorize, guide that which amino acid are ketogenic, which amino acid are glucogenic, which amino acid are both, and what do ketogenic give us? What do glucogenic give us? So we said that ketogenic will give us what? It will give us fatty acids and the ketone bodies, which we can also use as a source of energy or store them, right? Or we can, some of them are glucogenic, right, which are degraded to form various intermediate, as you can see here, various intermediates of the TCA cycle, right, which can be used as the glucose precursor. So these are all glucose precursors. They have been converted. See, look at tyrosine, phenylalanine, and aspartate. It was converted to form fumarate, and then it joins the TCA cycle in the middle, and thus finally forms the phosphoenol pyruvate and forms the glucose. And this glucose can be used as a source of energy as well. So that is how amino acids give us energy at various points of our life if you're not eating carbohydrates. Okay. So that's why if this chapter was based on not only how carbohydrates are used as a source of energy, how proteins and as well as the lipids are also used as a source of energy. And the last slide is, when you already know this from chapter number 10, RBCs, how they are metabolized. Globin can be converted into amino acids. Iron can be saved in the form of what? Ferritin, a protein. Okay. And the heme can be converted into bilirubin, right? Bilirubin enters into the liver, right? And then it's converted, it is sent to the gallbladder, where it is stored in the bile, and it gets excreted when the bile is released with the food, right? To emulsify the food. So it is also released and it's sent out of the body in the form of stercobilin. So this bilirubin can be converted into stercobilin, which gives yellow color to the feces or yellow color to the urine also. So no need to do this one. Okay. And then this is the diagram. This is basically, this is, it's just showing you everything. You don't need to know this diagram, but it's just trying to, it has collaborated everything. It has collaborated how your, ketogenic amino acids, or your both ketogenic and glucogenic amino acids produce the acetyl CoA. Here it's showing you how your glucogenic amino acids, right? How they join to form the various intermediates of the TCA cycle, right? As you can see here. Then it's showing you how how we started with, we had carbohydrates and how we converted carbohydrate, in glycolysis, how we converted into pyruvate, okay? And then how we converted pyruvate into acetyl CoA, and the previous chapter how acetyl CoA is used to produce the NADH, FADH2, which can be further used in the electron transport chain. It's basically this diagram is a collaboration of both the chapters, previous chapter as well as this chapter, right? And it's again showing you how the other amino acids can also join the various intermediates of the TCA cycle. With that, we finish the syllabus. The end. Okay. Congratulations to everyone. Finally. Okay, so the last chapter we are not going to take. I'm going to upload the syllabus on the Moodle with naming each and every chapter along with the details of the final exams. Yes, yippee, we finished it. Alhamdulillah, Alhamdulillah. Okay, now what are the various things which I wanted to discuss here? Okay, before we start discussing about the yes, Alhamdulillah, we're finally done. Yeah, before we start discussing about the you know about the research reports, I really wanted to let you know that one thing, that I'm going to upload the assignment 7. Okay, assignment 7 will be uploaded for these two chapters, because I was waiting for this chapter to finish up. Okay, since Mr. Hindavi has also finished it and I've also finished it this week, so by this Thursday or by this Friday I'm going to upload the assignment 7. Okay, as already discussed, that I will upload assignment 7. You will get to practice two chapters, two last chapters, chapter number 26 and 27, right? And at the same time, you all will be able to practice, and then at the end I'm going to drop one of the assignments and use the best 6 assignments for your score. Is that okay? Did you all understand? Yes, you can practice as much as you can, because as I said, that if I don't upload assignment 7, that means you will not get to practice these two chapters, which are equally very important, right? So that is one thing which I wanted to tell you, that. Okay. And the second thing I'm telling, because everything is being recorded right now. So one more thing I'm telling you that applies to your biochemistry as well as PHSF. People who were with me last semester, they know what it means, is that once I will upload all the grades, I want everyone to pay attention, boys and girls, everyone, because boys were not with me last semester. And I'm sure Dr. Mateen would have told you about it, right? So once we will upload all, for example, we'll check the lab reports for PHSF, or we'll finish the chapter 7 assignment here in biochemistry. I will finish the whatever issues we have with the attendance things, okay? Everything, then I will send you an email saying that your grades have been uploaded, and you can see your assignment scores. I will upload them from the Cengage into your Moodle. Once we have everything in the Moodle, and I'll give you a timing, okay, that if you have any concern about your, and even I will add the attendance bonus mark. Yes, dear, I do remember that. I don't forget that. No, 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 I do remember that. No, no, you had to, because I already explained that in today's class, so there's no way you can submit it now, dear. The submission was last Monday itself, because I explained it today in the today's class. Okay, so I was telling you that once I upload everything, then I sent you an email on the Moodle saying that if you have any concerns about your attendance, about your assignments, about your midterm 1 grades, midterm 2 grades, please send me an email up to this time, right? For example, I might send you, please send me an email by 2nd of April, or 2nd of May, for example, right? So that means you are going to bring issues only to me before 2nd of April. I will not be able to make any changes in the grades. By that time, I would have finished grading your research reports as well. So please make sure that after second of May, for example, I will not be able to make any changes in your grades. I hope everybody, I'm recording this also, so that tomorrow nobody should come to me that, oh, I have less grades in my assignment, or I have an issue with the attendance. Please bring, this is the time, if you think that your attendance issues have missed, resend that email with, if your email has been missed, maybe you did not write the dates properly for which you had an attendance problem, maybe you did not write PHSF or PBio. I cannot, for example, if you send me an email about attendance, I need to know, is it for PBio or is it for PHSF, people who are, with me in both the courses. So send me, this is the time when you all need to be active about your grades, because once that deadline is over, right? So don't ever expect that I'm going to extend that deadline and I'm not going to make any changes. Not only me, not even any professor is going to make any changes about that. Did I make it clear to everyone? Yes, ladies and boys. Once I send that, after that, even if it's a 0.25, I will not be able to add that 0.25 to you. So please send me all your concerns. Okay. Once I upload everything on the Moodle, right? And I will send you an email. Okay. So please send me all your concerns before that. Okay, I will send an email. I will send an email. Maybe I'm planning to have it 2nd of May. Yeah, I'm planning to do it 2nd of May, because 28th we have exam. Maybe 29th and 1st I will be grading your final exam paper. Okay, and then yeah, 2nd of May should be fine. 2nd or third of May should be fine. Okay, dear. Yeah, everybody. Okay. And now I wanted to discuss about the research reports, but give me a minute. I wanted to upload something here first. Give me a minute for that. Okay, you can just take a 2-3 minutes break. Meanwhile, I will upload something and then I will let you know what I'm talking about. Okay.